Hi everyone, so in this video we'll discuss about a great problem. What question says, we are given two strings, string S and string P. We have to find whether string given as pattern can represent string S. This is our question, okay? Can P represent S? Now, there can be a question mark or an asterisk as well in this pattern string, okay? A question mark means this can match to any single character, and asterisk can match to any sequence of characters or even nothing. We can just discard asterisk. Let's go here. So suppose my S is said to be like AA, okay, and P is given to be just star A, okay. So we understand that this star would be representing this A and this A is representing this A. So for this, my result should be true. Okay. Suppose I got another substring string which is A, B, C and P as star A star, suppose. So I can say that this asterisk or star is for nothing. We can just discard this. This A is corresponding to this A and this star is equivalent to this B, C, this string or substring you can say. So because we can represent this A, B, C with this, so again result is true. Let's take another example. Suppose my S is AAB and P is A question mark B. Okay. So I hope you understand that A is equivalent to A, B is equivalent to B, and question mark is equivalent to A. So again result is true. Suppose my S is AAB and P is A question mark asterisk. Now I'm expecting you to understand that A is equivalent to A, question mark is equivalent to A, and asterisk is equivalent to B. So my result is true again. So I hope you understood how we are checking if something is valid or not. So I'll draw now. If we are given a string S and a string P, then I will just check this character and this character, okay? And if they are same, then I will call my function, you can say recursively, for this, and same way for this. So this is first thing, if they are same. So let me write it for algorithm part. This is clear observation. Let me increase size as well. Again 22 should work. So first observation is that if first characters are equal, look for strings ahead. Okay, I can say recursively or dynamically, that's the second thing. A part of it, what we have here is if they are not equal. Okay, so I hope you understood this thing. I just missed in between. Yeah, it's recording. So there is a possibility that both of these characters are equal. So if characters are equal, then look for strings ahead. So if they are equal, then look for this part and this part. If there is asterisk over here, then there are three possibilities. First one is this asterisk is equivalent to nothing, and this whole thing with this whole thing. Okay, and let's go for second possibility. Second possibility is that this asterisk will be equivalent to just single character. That is another possibility, right? So for that I can take this part Okay, so this asterisk is equivalent to a single character, which is a possibility, and we will look for this with this. Now third case is that this asterisk is taking this character, but still it's not over. This asterisk will show some more characters ahead. So this is third possibility. This is actually crux of this problem. I hope if you don't understand, then you can rewatch this part. But it is important that first an asterisk can be equivalent to a character, an asterisk can be equivalent to nothing, or it can be equivalent to some more characters including this. So let me write it again. Up to here. Now another thing to notice is that there can be a question mark over here, which will be equivalent to single character for sure. There's no choice for that question mark. So if question mark is there, then I need not to write in points for this. Then that is equivalent to single character for sure. There's nothing more or less in this. So I hope you understood these things. Now, a part of this, we need to look for base case. Now let's see what our base case is. For that, I will remove this, and this. Also this. Now, what I mean by base case is that when I look for these characters, then I will definitely consider strings ahead. Okay, I'm just comparing these two characters. So there is a possibility that we will compare these two characters, this one and this one, and we can either look for this thing. So we have to consider the case when we are looking for something which do not exist. Okay, so suppose I represent position for first string with I. So if I is equal to size of the string, then I'm to handle that separately. And if I'm representing position in second string with J, then I'm to consider that J should not be greater than or equal to size of this string. So with that being said, let me write it here as well. If both are equal and equal to size of their respective string, then answer is true. Because if someone says that is this empty part equivalent to this empty part, then yes. If these two characters are equal, suppose, then it will check is everything ahead also equal. So in that case it should return true. So if both are equal and equal to size of their respective strings, then answer is true. After this, we will be moving to coding part. So let me revise this again. If first characters are equal, then look for strings ahead. If asterisk is there, then there are three possibilities. Either asterisk is equivalent to nothing, asterisk is equivalent to single character, or it is equivalent to a substring. Okay. If question mark is there, then it's for sure equivalent to a single character. There is no choice for that. If I is greater than equal to size of s, then that is another case to handle, which is base case. If j is greater than equal to size of p, then that is another base case. And if both are equal and equal to size of their respective strings, then answer is true. Now, if you can do this thing with recursion, then this thing will work but will show time limit exceed after certain test cases. So we have to implement dynamic programming in this. Now, to implement dynamic programming, we have to store everything in some arrays, because for a particular I there can be certain values of j, and for certain j there can be some values of I. So we will have a matrix of size of this string plus 1 cross size of this string plus 1. We understand that, okay? And we'll store result for them in that array of boolean, because our result is also boolean. A part of this, I will have a map whether we have a result for a particular ij or not, because for boolean there will be either false or true. How would I know that it is a result or it is a garbage value? So to know whether I have computed for a certain ij, I will maintain another unordered map. This is a big thing, and definitely it is hard problem, so you can take some time to think. And now I will move to code part. So let me show you this. Here's our class. I put string AB just for ease, and I won't be passing string every time, but to compare characters I need to have strings. So there are global strings, and size of a is 0 0. I could just leave them uninitialized, but just write it like this. Then result of this, which is actually a matrix of maximum possible sizes of both the strings, and an unordered map, okay, which has an integer which will represent I, and it is mapped with an unordered set. Available patterns for this: dot find j or dot insert j. I hope this makes sense to you. And this is the function given in our question. It has a string passed as parameter, so we can't use this because I actually used strings, but that got me TLE. That's why you can see there are a lot of TLEs in submission part, 3 TLS. So then I decided to go with integers. So what I did in this given function, I initialized a and b, the strings for global use, size a, size b with size of these two strings, and I'll return is match. Okay, the same name but cases are different, so is match. And I pass just 0 0 because we will be comparing elements or characters at position 0 0 firstly, and then we'll move ahead. Okay, so this is the definition of our main function, which will be working recursively and will do everything we discussed in our algorithm. Firstly, it will check base case. So if I is equal to size of A and J is equal to size of B, then we know that we have to return true, because now there's nothing to compare, so they are equal. Empty string with empty string is equal, okay? If I is less than size of A, that means there's something remaining in string S. In our actual problem, there's something still remaining in string S, but j is equal to size of B, but there's nothing in string P to show that, so there is answer false. Now I could also consider I is equal to size of A and j is less than, but we will do that later because we are having results, so we will first check if we have calculated it already or not. I did these two things firstly because they are just constant time thing, but this thing is not constant time. So if in available patterns for I find j and that is not equivalent to end of available patterns for I, then I will return result of ij. Simple. If I is empty, there's nothing in string s, but there is something in string p, then what we will do? Now I'll make my index move from j to end of this string p, which is represented by b, and I'll check if something is not asterisk there, then there must be some other characters also in S to make P represent S. So if there's no asterisk, then there should be something in string S, which is not in the case. So result of ij is false and we will return false. If this condition never works, then we understand that everything was just asterisk and result of ij is true, return true. You may just rewatch this if it is getting too hard to understand. And I have also checked for DP, okay, pre-computed results. After this thing, anyone might be empty. This case is over. Also, DP part is done. Now let's move to non-empty case. That means none of the I and j are at end and we have to do something. So if none of them are at end, then there are two possibilities that we will check for strings ahead in both S and P. If current characters are equal or character in P is question mark, this means that current characters are equivalent, and we will calculate result for I plus 1 j plus 1 and available patterns for I dot insert j, because we also calculated result for this. Result for this is what we calculated here, and return result. So this is the case when we have equivalent characters. Now what if bj is not asterisk, bj is not equal to ai, bj is not question mark, bj is not asterisk, then there must be wrong. So it can't represent. So available patterns for I dot insert j that we have calculated for this I and j, and result for this ij is false. Also return false. I hope this makes sense. And now the ultimate case, where I told you three cases: asterisk equivalent to nothing, equivalent to single star, equivalent to more characters, or basically a string. So result star ignored. I'll calculate for it, store it in boolean, is match, I is here and j plus 1, because asterisk has nothing to do with it. So here is first result. Now result with star takes one character. So if it takes one character, then asterisk gone and one character from string s is also gone. So I plus 1 j plus 1. And third case is that the result when star eats more characters, that means it will represent a string which is not over yet. So is match, okay, I plus 1, because the character at I is represented by asterisk, but asterisk will represent more characters. So j will stay as it is and I plus 1. I calculated results for all three cases and will store ultimate result in this variable, in this boolean. And now if any of these three are true, then my answer should be yes. We can represent S with P. So I'll store result here. Available patterns for I dot insert j. Okay, because we know that we have calculated result for this as well. Now result of ij is this, my result. Okay, and return result as well. So I hope this makes sense to you. If it don't, then check out it again. I just submitted it and it is actually quite slow. I'll try to optimize it, but let me know if you have any suggestion in the comments below. Also make sure to check out description and let me know if you have any doubt in this. I will try to clarify that as well. Thank you so much for watching this video. See you next time. Bye bye.